All right, so it's 2 o'clock. 2 o'clock on a Thursday at ChefConf. So what was going to be my co-presenter and I thought that, first of all, this title wasn't going to draw in many people for a Thursday afternoon at ChefConf before House of Blues. I guess I screwed that one up. So what we were thinking of doing is this doesn't really capture, I think, the crux of our talk. It's very generic, test-driven DevOps. Okay, what does that mean? So we were going to come up with a new title right before we jumped in to speaking, and that's when Nathan sent to us, hey, here's your title slides. So we were stuck. But in the spirit of ChefConf, what I'm going to do is I'm going to break some shit, and I'm going to do some change. So we went through and we tried to come up and brainstorm with a few other ones. So if we wanted to get something a little more descriptive, harmonizing disparate and diverse environments by continuous end-to-end testing and visibility. All right, well, that's a little too wordy, we figured out. So we decided then to go with, just keep on testing, right? Not enough. That was Keith, my partner's. He's a Dr. Strangelove guy, I guess. Then I called my analyst friend out in San Francisco, and she gave me that one. Feels good, right? I mean, I love Silicon Valley. So what we settled on was this, okay? Test-enabled deployment and using tests as a common language. I'm going to get into some of the challenges we have in the federal sector, but one of the biggest ones is communication. And that's kind of what we're going to focus on a little bit here, in using testing and certain tools to get people all on the same sheet of music. So we're Tapir Technology. We're a small firm focused specifically right now on the federal sector. We've been in business about 15 years, but incorporated for about 10 or 11. We have 40 employees right now. We're very small. But 95% of those folks are cleared at top secret and higher. So we're very focused on the DoD and the intelligence community. We have folks in the Washington metropolitan area where we're headquartered. Tampa, down at SOCOM. Denver is our software-defined radio office, which I actually lead, which has nothing to do with DevOps, but it's cool, so I mentioned it. And then we have folks in Afghanistan. We have about 10 folks right now deployed with soldiers in Afghanistan, and we do a lot of technical support enablement in the actual forward theaters. Afghanistan, we've done Iraq, Jordan, a few other places. Our focus is software and systems engineering, infrastructure as a service, and what they call C4ISR. Command, control, compute, intelligence, surveillance, and reconnaissance. So we work a lot with the DoD, we work a lot with the IC, and anyone connected to that. Here's some of our customers. You may have heard of a few of them. They're kind of small, but, we give them what we can. So Keith was going to be my co-presenter. Here's his information. He's our Director of Partner Solutions. He's a rabid Rubyist. He does Ruby for Good. He does a lot with First Robotics. He's a absolutely phenomenal technologist. He's pretty much our chief DevOps evangelist, whether it be straight Ruby, just concepts, or Chef. Unfortunately, Keith, as we say now, is temporarily offline due to dad ops. He just had a child 48 hours ago. So good job on him getting his wife pregnant exactly 9 months before ChefConf. But either way. Thanks, Keith. I'm Chris Todd. I'm one of the co-founders of Tapir. I've been working in the intelligence community since before then, since 2004. So I've been spending about 14, 15 years directly in the IC. I myself am a dot-com era survivor. I came out of college right in the dot-com boom, started working for a startup. That imploded on September 10th, 2001. That was a good day to get laid off. And ever since then, I've been working with the IC, and most recently working to bring things like Chef and Automate into the IC and try to foster change. I'm currently working, though, on a non-IC project. I'm currently working on the GPS program, working to bring DevOps and Chef and InSpec in there and help them out. I'm also, like I said, director of our software-defined radio project. I suggest you check it out on our website. It's just cool stuff. Has nothing to do with DevOps, but it's rad. And I'm from Monument, Colorado. So, we work for the federal government. What does that mean, right? Intelligence, defense, transportation, infrastructure. We get to do some really cool stuff, okay? We work with satellites. We work with communications. We work with mapping. We work with human intelligence. All the kind of things that you would think of as cool intelligence stuff. The problem is we do work for the federal government. So the federal government has a lot of money. It does a lot of cool stuff, but it's also the very definition of bureaucracy. So risk averse. Everything in the government is driven on risk. It's very slow to embrace change, especially in what we call darker corners, the things that are paranoid, secure. Security is pretty much the theme of the day now. What they call cyber, it's really cybersecurity. I hate how they abbreviate that, but it's pretty much everything runs on InfoSec. A lot of this is not without good reason. You've heard the stories, I'm sure, in the news. Things happen. I myself have been affected by things like the OPM hack. There's always a constant drumbeat of security in the government, and that makes people paranoid and not being willing to change things. Given that, there are a lot of interesting problems to solve in the DoD and the IC. And it's extremely rewarding when we actually do influence and change. So I can even speak for myself in the last 15 years. I have seen the threats, and I have actually been relatively closely connected to things such as loss of life when things do happen bad. But I've also seen things where definitely lives have been saved when the good things happen. So it's a double-edged sword with the government. With that, the federal sector really, really badly needs DevOps. It really needs to be more, I hate to use the word, agile. We are all paying for it. Everyone in this room, I don't care if you're not even from this country, you showed up here, you're paying for it. You go buy something, you're paying for our DevOps, you're paying for our project, you're paying for everything we do. Yet risk rules all, so we have to balance that. Sometimes that risk is based just on perception. Sometimes it's imaginary. Sometimes it's about accountability. Politics are very real, okay? 2013, when we had the sequester, our company has never laid anybody off, but the closest we ever got was during that sequester, when we all got a 3-week free vacation. Projects got delayed, pushed to the next year. Things didn't get done. Intelligence was not moving because projects didn't get done. So when you think about all this stuff going on in the news, all this squabbling on Congress, and think, oh, it doesn't really affect me. No, it does. I guarantee you it affects you. You might not see it, but it does. And again, our biggest problem is bureaucracy. So we have these unique challenges, right? We can't pivot as fast as another team. We can't just go say, oh, we're going to do Habitat. You know, I really, really loved Adam's talk today. I want to agree with everything he said. I really do. But there's some things that, as engineers and developers, we can't change. Sometimes the environment's on our own. You know, we have layers of contractors. We have things that are split by classification or who owns it or what agency owns it. And you literally need an act of Congress to change that kind of stuff. We deal with restricted software lists. We used to have a thing called the approved program list, which would be updated roughly once a year. So try getting even an update to InSpec, or when InSpec 2 comes out, or when Habitat comes out. It's just not going to happen. You're 2 or 3 years off. Air gap is real. I've been having trouble trying to talk about that a lot here. A lot of folks that are in startups and in the more agile parts of the industry don't get that. But we have places that are completely walled off from the internet. There is no internet. And it's never going to change. It's going to. We deploy software on submarines. There's no internet on a submarine. It's never going to happen. There's a long tail of procurement. If you want to buy something, you get it approved, you might see it in 18 months, maybe, if things are working really well. I know Chris Nimmer from Chef has had that pain. He shared that with me when we try to get our Chef renewals. Sometimes a single program office doesn't even control everything they're doing. It can be supported by multiple contexts with legally separated entities. So one is not legally allowed to work on what the other one is. So someone might be controlling an environment. You might have what's called the LSI, doing the large-scale integration. And then you have the system concept design, which comes up with the ideas, but they can't touch it. Or vice versa. You might be working on either. So these things are legally separated. I don't know why. The government does some strange things, but it's just true. And then we get into the whole classification thing, where there's a special access program, or SCI. the work has to be done by somebody else. Not everybody's cleared. Not everybody can be cleared. We split the contract sometimes between one large integrator and another, just by matter of trying to spread the money around. And then we have our external oversight. Congress, you all know about. We have the FFRDCs like MITRE. Everyone's always watching us. So it's not as simple as going up to the VP and convincing them, hey, Habitat's a great idea. You've got hundreds of people that you've got to change their mind, change their culture, and a lot of them are very stoic and stayed. But on the other hand, we're not exactly so different from the rest of you guys. Really, the federal government is just another large enterprise. We've got agencies, directorates, departments, and centers, but it's just another org chart. That's all it is. People are just people. They're not special because they work in the government. The challenge, of course, is that the teams speak different languages, which is something you guys all see all the time. You might have one shop that's full of old Java programmers, one place that's full of Ruby programmers, some sysadmins that are raised on AIX, and another one just using Fedora. It's disparate, but people talk different ways. You've seen similar challenges in healthcare, finance, transportation. There's legacy apps everywhere. There's a long-lived infrastructure. There's on-premise data centers. Environments are never consistent, and things become disparate and historical. And once you build a system, people move on, and that thing decays, and it never gets updated. And all this technical debt has interest. So you end up with systems like this. Now, I'm saying, I assure you, this is mostly real. I can't talk about exact environments or someone would roll up in a black truck and whisk me away. But sometimes our integration environments, our staging, they're not even run by the same people, for example. We have a contractor maybe that might be deploying things while we're building it. The classified side, sometimes you can do new stuff like AWS, but the old stuff, the unclassified stuff. The classified stuff, you have to stick with something like an old VMware stack from VMware 6 or something like that. We can do KVM and Docker in development, but once we push it over to that side, it's nothing like that, and we can't even affect that. It just is what it is. And then once we get to production, sometimes it's bare metal. Sometimes it's something nice like vSphere if we're lucky. But the classified environment, there's not a whole lot going on in the cloud. There's C2S, which is a subset of Amazon. We've got a lot of that. But a good portion of the time, we're still pushing the straight servers. So this is a not untypical government agency pipeline where we can do some cool stuff in development, like using Docker and InSpec, but once we push to integration, apps get split up and we have different environments. Staging then is completely different too. Maybe it's run by someone an ops group who again is a different contractor, and they're using ESX and they're on C2S, and maybe they've got some InSpec and they're doing compliance, but they're not touching our InSpec or in our compliance, and we don't see that. We get no feedback from them. Production, they drop all the testing, and all they care about is security in production, so they're doing that on bare metal, and they're running some compliance. But again, we're not part of that feedback loop. So any changes they say here, well, they're going to keep them. They're not going to tell us. Even worse, you get an audit guys come in, and they say, well, we don't like really InSpec. We're going to use App Detective and throw that in there. So we're going to do that early on and prove your stuff and keep that in the pipeline, but we're not going to tell you what changes that you should do. We're just going to yell at you and say, do this, do that, but we're going to keep that code to ourselves. Same for InfoSec. They're going to throw Nessus in there, and they're going to run the STIGs through Nessus. Well, we're running it through compliance too. So you have differing and competing interests all the time because everybody's kind of fragmented. Oh, and I didn't mention there's a firewall between integration and staging, and this is all air-gapped, and there's only one-way transfers. So in all the model, we're not doing any environment checks. We're not saying, oh, is this consistent? Is this something we can deploy to? So occasionally this breaks, once in a while. So how can we make this better? When you can't change the actual environment, the best answer is to illuminate that environment. Get visibility and get transparency out there. What we call this, when we've been talking about, is declarative communication. Something unambiguous. Something where you can just say, this is what it is. This is broken. This is what you need to do. Something that's continuous and portable. Nothing that requires a big license install. I've talked to a lot of the great providers here, the sponsors, that have monitoring systems. And I'm like, well, can you guys do this in an air-gapped environment? No, not really. They're fun. Sensu sounds like it's great, and they can do some stuff. But again, it's not something we can port from all these environments to an environment. We want to also build these changes to light before the build breaks. We don't want to test afterwards and say, what happened? We want to make sure that we can deploy and actually put stuff out there before we see that our pipeline's broken. the state of the deployability of the environment, not just the code we're putting out there, should be accessible to every stakeholder, whether it's another contractor, whether it's another development group. They should always be able to see if things are set up for them to deploy. So what I called it was a Rosetta Stone that we need excuse me, for system requirements across teams. The problem that we have is things break due to disparate, diverse, and unusable environments, and chaos abounds. But if we do a few things, we can maybe rein that in. Number one, if we capture our failures, they'll be documented. Once they're documented, they can be organized. And once they're organized, they can be triaged. Once we triage them, we can focus on them by team. And once they're focused, we can actually work them. So there's something that you can use for that. And we found over the past few years that InSpec is a great tool for that. It lets you annotate and communicate requirements in testable code. You can handle requirements from multiple teams, platform development, security, environments, anything that you put in there. InSpec has a lot of things, and I'll show that in a second, that you can test, obviously. InSpec is amazingly easily readable. One of the problems we've had is when we deal with InfoSec, if you're doing straight code, they're going to be like, I don't know what this is, guys. You know, I'm not a developer. Just tell me, is my cert expired? Show me you're asserting that these SSL ciphers are actually turned on. Well, InSpec, you can do that. It's really simple. It's declarative and it's unambiguous. It allows us to assign priority. We can say, well, this InfoSec stuff is much more important than these nice-to-haves. We can reuse it and extend it and reference it by context. So if we have a classified environment, we can still point to the same profiles, but we can extend it with secret or top secret additions to those profiles. It's lightweight. We don't need a server. We don't need licenses. We can move it around. It can live by its own. It can live with Chef. It doesn't really matter. We can just easily port it from place to place. So Chef sells InSpec as compliance. You guys have probably all heard about that. And it's great for that. It provides visibility to security and compliance. A lot of you guys might be using it for that now. So just real quick, when we're talking about compliance, we're talking about things that break the rules, put their system's assets and resources at risk. Those risks are legal liability, theft, unauthorized access, chain of command, chain of control. And then the alphabet soup that you all know of. Pick yours. You've got a few. I know every one of you does. So this is a great example of a compliance example in InSpec that I would say for most folks with any level of technical knowledge is fairly easily readable. We're saying these are two actual STIGs. Windows RDP saying that we need to have a certain encryption level set. SSH, we want password authentication off. A security person can read that. A sysadmin can read that. A developer can read that. It's not something where, oh, you've got some weird API that you're talking to. This is actually as close to English as you're going to get for describing these high-level concepts. InSpec is also used a lot for functional integration. A lot of you guys are probably using InSpec in your kitchen tests. It's really good for testing your cookbooks in a sandbox. The problem is that often gets stuck in the development world. You know, you run your InSpec tests, my unit tests are great, all right, fine, I'll ship it. But you're not sharing that with other people. It answers basic questions like, is my software installed? Are my configuration files in place? Do they have the right settings? And did my cookbook do what it's supposed to do? If you're doing that, fantastic. It's something everybody should be doing. Even if you're using Puppet and Ansible, God forbid, use InSpec. It doesn't depend on Chef. InSpec is a tool for everybody. It's part of the Chef stack, but it absolutely has zero marriage to Chef, and that's something I've been trying to hammer to people. So here's a good functional example, and if you guys ever have taken your badges, you know these ones pretty well, I think. Making sure services are on, making sure ports are open, things that make your application work. Very simple, again, for people to read. And the list of things you can test, and we didn't even get through everything here. I think we got to part of the AWS, and this is InSpec too, but it's going to keep growing and growing and growing. InSpec can look at every part of your environment, and if not, you can write a custom resource. There's really no reason that anybody in this room, I think, shouldn't be using InSpec. So what can we do if we want to expect a little bit more from InSpec to try to unify this? Can we go beyond compliance? Can we go beyond functional unit testing integration? How do we test how multiple VMs are integrated? What about when we deploy from one stage to another? What about outside your own teams? How about things that aren't covered by your cookbooks? I bet a lot of you guys in here, as automated as you are, there are still manual steps. I know we have manual steps. There are always manual steps. And InSpec, again, doesn't have to be stuck to Chef. A lot of people that are developing cookbooks, I see them when I'm mentoring them for teaching them how to do InSpec. They'll say, oh, well, it's part of the cookbook. It's part of the directory structure of the cookbook. Yes, it is, but no, it doesn't have to be. We want to get InSpec working outside of the cookbook and compliance world. So step one, get InSpec everywhere. That's our first thing that we want to do, and that we did in a certain agency that we worked on and wanted to deploy this stuff to. InSpec is so much easier to explain to gatekeepers than things like, and by gatekeepers I mean your ISMs, your ORBs, your boards. It's so much easier to explain than Habitat or even Automate. You're saying, all I'm going to do is go out there with a rules engine and test and enforce, not necessarily even enforce, just check for some rules. Like, oh, more information, that's great. Nobody's going to complain about that. Run InSpec as its own entity. Don't stop thinking of it as tied to Chef. Run it everywhere. InSpec is light, it's easy, it's compatible with everything. Just put it out there. I don't care if you're not doing anything. Get it out there. Just like the old idea of putting the Chef client everywhere. Get InSpec everywhere. And the key part here is that you're going to publish your tests to a common meta profile stream. And we'll talk about meta profiles in a second. You're going to guard your controls by context, so you're not going to get any false alerts if you don't need to. And you're going to collect your output in an organized way. But clearly, the other thing that we want you to do is to run InSpec before deployment as well as after. So you're going to bring tests into your profiles that pre-flight your environment and say what is right and what is wrong in my environment, what do I expect before I deploy. Not only apps, resources, and we'll talk about what that is. And again, here's just a simple example of how you can run InSpec on your own if you haven't done it before. InSpec exec, dump it out. It's real easy. So step two, part of getting that to that point is to migrate out of your cookbooks and get to profiles. Use profiles. There's no reason, even in your unit test, that you shouldn't be using profiles. Decouple from your cookbooks, test where your cookbooks don't cover. Profiles let you organize, reuse and extend, annotate, and publish things outside of your enclave. Your cookbooks, your tests now are their own independent entities that can be shared with everybody in other teams. So here's an example of a profile. I think a lot of you guys have seen it before. The key being that it doesn't live in your cookbook. It lives in your repos. Okay? And it can be named DevSec SSH or whatever it is in your classified environment or in your unclass environment. But you can keep your deltas here for your top secret or your JWICs or whatever other configuration you have for a different domain that doesn't run if you're not in that domain. You can keep things separated but still inherit from the same base test that you reuse everywhere. It's extremely self-documenting. Nobody likes to say, all right, well, how do we fix that? What's wrong? Well, look in the wiki. All right, so you're searching the wiki and you find 5 entries from a guy who quit 5 years ago, and it doesn't tell you anything. This lets you actually point exactly to where that reference is. Now, of course, that requires a little discipline to do that, but InSpec allows it. There's nothing stopping you from pointing to a wiki or even putting right in there exactly what you need to do. Here's a CIS benchmark where we're pointing exactly to the issue that we're looking at right here. So the bigger picture of all this is using meta profiles. I know a lot of you are familiar with wrapper cookbooks. If you want to change something in a cookbook, you write a wrapper cookbook, make it your own. Meta profiles let you group these things into one pointer, one base where you can actually point at and say, run all the things, okay? So you have a Linux meta profile, and it does your network, it does your storage, it does your environment connectivity, and it's the base profile that every team contributes to, whether it's InfoSec development or infrastructure. The things that you're going to look for outside of your cookbooks are things that halt, degrade, or impede functionality, usability, performance, or availability. Your implied prerequisites, things like DNS entries, storage availability, storage capacity, whether hosts are even reachable, APIs are available. The network configuration, are things in the same subnet? Are things grouped together? Are there bonded at Ethernet adapters? Are things named right? Naming is one of the biggest problems that we have. What about things that are controlled outside of your CM pipeline but are still automated? SCCM, we have a lot of spacewalk, ad hoc patches, and manual steps, patch Thursdays that we have. Anything that you take for granted and anything that you broke before that's not part of your app should be in those base profiles and organized. So here we are back to our disgusting, well, For a government person, that probably looks pretty good, actually. They probably think that's pretty normal. Here's our old pipeline. So again, the first thing we do is we run these profiles as pre-flight checks. We run them continuously, and when we detect issues, the staging team, let's say we detected right now that a SAN wasn't mapped. Okay? They create a test immediately, no approval process. They're all contributors to the GitHub repo. And they're saying, all right, well, I'm going to check for my LUNs. And that now becomes the new profile. It's part of the new profile, part of the staging portion of the new profile, of the storage portion, I'm sorry. And then they merge that back to master, and everyone can use it. The next step is you get all teams. Now, this is the hardest step, of course, getting all teams to contribute to that base profile. But if you open it up and you start actually testing different parts, people are going to want to contribute, and I'll explain that in a minute. So get all your teams contributing to the same repo on that base profile. You can do some deltas if you want for classified, because there's their own teams working in there usually. It's still compatible with doing that. And then you're going to be continuously testing. The first part of the loop is to triage, categorize, document, and then you add to your base. And then when you come back, you can implement, annotate, and redeploy. Keep doing that. Those are the best practices from test-driven development. So there is a bit of TDD in here when we're talking about this, and that red-green testing and the loop, the feedback loop that developers know well. Sysadmins should be doing it too. Ops people should be doing it too. That profile library then becomes your living knowledge base. It's a description of all the requirements, even outside the apps of your system. Organization is absolutely key. And that's what I meant when I said you're going to get people involved even when they're not buying in at first. Because if you can triage, you can blame. And blame can actually be a useful tool. And I'm not saying this in a non-collaborative way, all right? When you bring things to light and show something like, hey, you guys are doing something that isn't working and you're breaking a lot of other people, and it's there in bloody red on the screen, people are going to start responding. Then you'll get people to accept that. And with acceptance comes that accountability. So as long as you funnel things into the right groups in the right areas, people will start noticing, yeah, you know, our team it keeps breaking things. So maybe we should step up to the plate. And we found that they do. So the last step is just an overall idea of how we improve deployment confidence throughout the team. Number one is accepting that you can't just care about your own backyard anymore. Okay? We're not developers. We're not sysadmins. We're not testers. We're not InfoSec people. We're not program managers. Everyone's a technologist that is working on the technology. You have specialties that you add to and contribute to the team. And you may work in a team of like-minded people, but there's no wall between you. There's no difference. You're all working on the same pipeline and on the same product, and the product is that technology, just like Adam said today. Transparency is its own edict. That's what I was talking about with blame. Okay? One of the challenges, of course, is saying that everything that we do is enforced by force. You must. There's a rule. There's a process. Well, humans are pretty good when you shine light on them and show them something's wrong. They either run away, and that's a problem that you have to deal with on your own, or they say, okay, yeah, you got me. All right, we're not keeping up to what we're doing, so we need to get involved. By showing that, by making the whole team aware where the pain points are, automatically kind of brings people into buy-in. And the good part about that is really everybody wants the same thing on these teams. Security, dev, ops, I don't care who you are. You want repeated, successful, and safe deploys. That's all the reason you're there. It's not like people seem to think that the goals of these teams are conflicted. They're not. Okay? And that is a culture problem, but they're not. Everyone's on the same page and trying to do the same thing. This InSpec will get people speaking the same language, communicating, literally playing off the same sheet of music. We're describing all our problems across different environments in that same language. And everybody's contributing back to that same test stream. So we're now all on the same page. We have that Rosetta Stone. We know where our problems are, we know what our requirements are, and everybody sees what's wrong. Things are going to fail still. Okay? That's good. That's a fact of life. Embrace that things are going to fail. My way of saying that is to fail loudly. Okay? We've worked with a lot of Java folks in the past and a lot of C++ folks that like to catch their errors. And I understand that as a developer. I was a developer, then I was a sysadmin, then I was a developer, then I was a sysadmin, then I was in DevOps. So a lot of people like to say, oh, I'm going to catch my error. So we would see chef runs where, something blew up horribly, and you just see one line, oh, an error occurred, please check the log. No, please don't do that, okay? Fail epically. Let things explode. Let things be as visible as possible, and then fix them together. When you fail loudly, this is good, okay? When things fail, you write a test, and that's communication. It might not be the best. You're not writing documents. You're not making wiki entries, but that test is communication. Those failing tests always start conversations. A big red dashboard will start a talk, I guarantee you. The failure is good. Nobody should be ashamed of it. It means change is about to happen, okay? Failure means that you're going somewhere. That unified test stream that we're all contributing to lets us cross these imaginary boundaries that we don't really have and that we have to get over. We're using a technology to do it that everyone can understand. Fix that thing, connect that fix to the docs so people can have a historical record, update that test base, and repeat. Keep that as a living code base and make those pain points visible. This comes up with you've heard the term emergent design, okay? Where you don't have a design, but through repeated and iterative processes, you come up with this design. This is something I would call emergent DevOps. You have a system that's chaotic. You don't know the requirements. It's legacy. You inherited it. You don't know what to do. If you keep doing this, you're going to build your requirements from nothing. You're basically automatically reverse engineering your requirements by testing all the things and keeping that going. We're building a codified design. And then there's a side effect. And the side effect may not be actually the side effect. It may be the real intent of this approach. And that is to actually infect culture. Okay? So InSpec, I have found, is one of the best infection vectors for the chef culture. To get in there and inject that idea of people working together, changing, breaking things, and making things work. InSpec is the easiest way in to convince people and then turn up the heat on that boiling frog in getting people to come over. So I challenge you all to do that and come up and walk in innocently, like, oh, I'm just going to do some testing, and use that to build an incremental revolution in how you do things and communicate. That's all I have.